Everyone. So in the discussed examples on initial and final value theorem and examples on this inverse Z transform. So in today's class also we'll discuss examples on this inverse Z transform by using partial fractions. So let us first will recollect here inverse Z transform. So we have already, we know, so Z transform of un is equal to u of z. So this is by definition taking z this side. So z inverse of u of z is equal to un. So z inverse, so this is a inverse Z transform operator, and z inverse of u of z is equal to un. So this is called inverse Z transform, right? So we know, so what is Z transform of 1? So already we have discussed this. So Z transform of 1 is Z divided by Z minus 1. So we want inverse Z transform. So inverse Z transform of Z divided by Z minus 1 is 1. Similarly, Z inverse of Z divided by Z minus A is A raised to n. And Z inverse of Z divided by Z minus 1 raised to 2 is n. And Z inverse of Z square plus Z divided by Z minus 1 raised to 3 is n square. Z inverse of Z cube plus 4Z square plus Z divided by Z minus 1 raised to 4 is n cube. And Z inverse of AZ divided by Z minus A raised to 2 is equal to A raised to n into n. So here we have applied damping property. So Z transform of A raised to n into n is Az divided by Z minus A raised to 2. So inverse Z transform of Az divided by Z minus A raised to 2 is A raised to n into n. So by using Z transform, we are defining Z inverse transform. Standard forms of this Z inverse transforms, right? Similarly, Z inverse of Az square plus A square Z divided by Z minus A raised to 3 is A raised to n into n square. Z inverse of Az cube plus 4A square Z square plus A cube Z divided by Z minus A raised to 4 is A raised to n into n cube. So similarly, we can define A raised to n into n raised to 4, A raised to n into n raised to 5, so on, right? With this, so let us solve a few more examples on inverse Z transform. So today's first example, already we have solved one example in the previous class. First example is find the inverse Z transform of Z plus 3 divided by Z plus 2 Z minus 4. So this is U of Z. This is U of Z. So what is given here? U of Z is given. So we need to find inverse Z transform of this U of Z, right? So let U of Z is equal to given data Z 2Z plus 3 divided by Z plus 2 Z minus 4, right? Next, so first step, very first step is, so we have to bring this in standard form. So what is that? U of Z divided by Z, right? So U of Z divided by Z is 2Z plus 3 divided by Z plus 2 Z minus 4. So take this Z from RHS to LHS, numerator comes this side, denominator. So we want U of Z divided by Z. So this is equal to 2Z plus 3 divided by Z plus 2 Z minus 4, right? Now let us resolve this by using partial fractions, right? So consider this, right? Leave this over, right? Consider this. 2Z plus 3 divided by Z plus 2 Z minus 4. So resolve this by using partial fractions. So we have what here? Different linear factors. So we can write this as A divided by Z plus 2 plus B divided by Z minus 4. Right? Now, by proper substitution of Z, we need to find here A and B, right? So first, let us take LCM of this, right? So LCM is Z plus 2, Z minus 4, right? So Z plus 2 is there, multiply Z minus 4, and Z minus 4 is there, multiply Z plus 2, right? So if you are perfect, you can write this step directly. You can write this step directly. So next step will be 2z plus 3 divided by z plus 2, z minus 4. So multiply z minus 4, a into z minus 4 plus multiply z plus 2, b into z plus 2 and LCM. So this denominator is same as it is, z plus 2, z minus 4. So observe here. So LHS denominator z plus 2, z minus 4 and here RHS denominator z plus 2, z minus 4. So both the sides get cancels. What left? 2z plus 3 is equal to a z minus 4 plus b into z plus 2, right? So if you are perfect in this, so you can write this step directly. You can write this step directly. You can avoid this step if you want, right? If you are perfect, so after this step you can write this step directly, right? Now by proper substitution of this z, we need to find here a and b, right? So observe here. So if you make this as 0, you will get the value of b, and if you make this as 0, you will get the value of e, right? So here put z is equal to 4, right? So 4 minus 4 will be what here? 0. We can get here value of b, right? So put z is equal to 4. So here also you have to substitute 2 into 4. 2 into 4 is 8. 8 plus 3 is 11. I'll explain it once again. 2z is there. We are taking z as a 4. 2 into z, 2 into 4, 8. 8 plus 3, 11. So 11 is equal to, this is LHS. 11 is equal to, right? In RHS, in place of z, 4. 4 minus 4, 0. 0 into something is 0. Plus z is 4. 4 plus 2 is 6. 6 into b is 6b. So 11 is equal to 6b. We want b. So b is equal to 11 by 6. Take this 6 to this side. So b is equal to 11 by 6. Right? Now let us find a. Find a. So we have to make this as a 0, right? By proper substitution of z, we need to make this as a 0. So plus 2 is there. So in place of this z, you substitute minus 2, you will get this as a 0. You'll get this as a 0. Now put z is equal to minus 2, and here also you need to substitute. So z is minus 2. 2 into minus 2 will be minus 4. Minus 4 plus 3 is minus 1. Once again I'll explain. 2z, 2 into minus 2. 2 into minus 2 is minus 4. Minus 4 plus 3 is minus 1. So minus 1 is equal to, so in place of z, substitute minus 2. So minus 2 minus 4 is minus 6. Minus 2 minus 4 is minus 6 into this a. So a into minus 6, and b in place of z, substitute minus 2. Minus 2 plus 2 get cancels. You will get this as a 0. Once again I'll explain here. So in LHS, in place of z, substitute minus 2. 2 into minus 2, minus 4. Minus 4 plus 3 is minus 1. This is equal to, a is as it is. In place of z, substitute minus 2. Minus 2 minus 4 is minus 6. This plus as it is, right? Then see here, in place of z, you substitute minus 2. Minus 2 plus 2. So 0. 0 into something will be 0. So minus 1 is equal to minus 6a. So we want a. So a is equal to 1 by 6. A is equal to 1 by 6. Right? Now, this 2z plus 3 divided by z plus 2, z minus 4. This is equal to a divided by z plus 2. So, a is 1 by 6. 1 by 6 into 1 upon z plus 2 plus b divided by z minus 4. So, b is 11 by 6. 1 divided by z minus 4. Hence, u of z divided by z, this is equal to 1 by 6 into 1 upon z plus 2 plus 11 by 6 into 1 upon z minus 4. Now take this z from LHS to RHS. This is denominator, comes this side numerator. For both the terms you multiply z. For both the terms you multiply z. Right? So u of z is equal to 1 by 6 z divided by z plus 2 plus 11 by 6 z divided by z minus 4. Once again I'll explain here. So first find once again I'll explain. So this is u of z, this is u of z given data. So first bring this into standard form. So u z divided by z, in this form we want. So take this z to this side, right? Take this z to this side, numerator comes this side, denominator. So u of z divided by z, this is equal to 2z plus 3 divided by z plus 2, z minus 4. So you resolve this by using partial fractions. So consider this one. So this is equivalent to a divided by z plus 2 plus b divided by z minus 4. So by proper substitution of this z, find a and b. So we'll get here a as 1 by 6, b as 11 by 6. So here in place of a 1 by 6, in place of b 11 by 6. So we will get this step. We will get this step, right? Now we want inverse z transform of this, means un we want. So for that this you send, this you transfer from LHS to RHS. So this is in denominator, comes this side numerator. So transfer this from LHS to RHS for both the terms, for both the terms. So here multiply z, right? So we'll get here as 1 by 6 z divided by z plus 2 plus 11 by 6 z divided by z minus 4. We want inverse z transform of this. So take inverse z transform both sides, or apply inverse z transform both sides. So z inverse of u of z, this is equal to 1 by 6 z inverse of z divided by z minus of minus 2, because we have a standard result z divided by z minus a, z divided by z minus a, or else z inverse of z divided by z plus a is minus a raised to n. Z plus a is minus a raised to n. Otherwise, you bring this into standard form. So standard form is what here? Z inverse of z divided by z minus a, right? So this is a raised to n. So plus 2 we can write this as z minus of minus 2, because minus into minus is plus, right? So z minus of minus 2. So your a is minus 2. A is what here? Minus 2, right? Plus this 11 by 6 is as it is, z inverse of z divided by z minus 4, so, right? So z inverse of u of z is un. So this is equal to 1 by 6 z divided by z minus a. In place of a what we have? In place of what we have here? Minus 2. So minus 2 raised to n, plus this 11 by 6 is as it is. In place of a what we have here? 4. Z inverse of z divided by z minus a. In place of a what we have here? 4. So 4 raised to n, because we have a standard result z inverse of z divided by z minus a. This is equal to a raised to n, right? Now move on to next example. Find the inverse z transform of 4z square minus 2z divided by z cube minus 5z square plus 8z minus 4, right? So what is given here? U of z is given. So what is given here? U of z is, let u of z is equal to 4z square minus 2z divided by z cube minus 5z square plus 8z minus 4, right? So very first step is we want u of z divided by z. We want u of z divided by z, right? So see the denominator here, 4z square minus 2z. We want denominator z here. We want denominator z, right? Now take z common here, because z square is there, z is there. We can take z common from these two terms. So take z common. So inside will be 4z minus 2. Now transfer this z from RHS to LHS. So this is in numerator. So comes this side, denominator. So u of z, this is equal to 4z u of z divided by z. Transfer this from RHS to LHS. Numerator comes this side, denominator. So u of z divided by z, this is equal to 4z minus 2 divided by we can write this z cube minus 5z square plus 8z minus 4 as z minus 1 into z minus 2 raised to 2. Means factors of this is z minus 1, z minus 2 raised to 2, right? So u of z divided by z is 4z minus 2 divided by z minus 1, z minus 2 raised to 2. Now consider this, right? 4z minus 2 divided by z minus 1, z minus 2 raised to 2. So this is equivalent to a divided by z minus 1 plus b divided by z minus 2 plus c divided by z minus 2 raised to 2. So this is by partial fractions. Now by proper substitution of z, so find a, b, c. So take LCM here. LCM is z minus 1, z minus 2 raised to 2. So z minus 1 is there. Multiply z minus 2 raised to 2. And here z minus 2 is there. Multiply z minus 1 and z minus 2, because only one z minus 2 term is there, right? So multiply z minus 1 and z minus 2, and here z minus 2 is there. Multiply z minus 1. So you can, if you want, you can write this directly, this step, right? So denominator both the side get cancels. So 4z minus 2, this is equal to a z minus 2 raised to 2 plus b z minus 1 z minus 2 plus c z minus 1. Now proper substitution of this z, we need to find here a and b, a, b and c, not a and b, a, b and c, right? Now substitute 2. So substituting 2, so you'll get this 0, this 0. We can find the value of c very easily. And substituting 1, so you will get these two 0, so you'll get the value of this e, right? So let us put z is equal to 2. In place of z 2, 4 into 2, 8. 8 minus 2 is 6 is equal to, here 2 minus 2, 0, 0 into something is 0. Here 2 minus 2 is 0, 0 into something is 0. So for both these two terms, you will get 0. This 0 and this 0 plus. Now put z as 2. 2 minus 1 is 1. 1 into c is c. So c is equal to 6, right? Now let us put z is equal to 1. So substitute here z as 1. 4 into 1 is 4. 4 minus 2 is 2. This is equal to 1 minus 2 is minus 1. Minus 1 raised to 2 is 1. Minus 1 raised to 2 is 1. 1 into a is a. Once again, I'll explain. In place of z, we are substituting 1. 1 minus 2 is minus 1. Minus 1 raised to 2 is 1. 1 into a is a, right? Plus, and here you substitute 1. 1 minus 1 is 0. 0 into something is 0. Plus, you substitute here also 1. 1 minus 1 is 0. 0 into something is 0. Right. So, you will get here a is equal to 2. You will get here a is equal to 2. Right. Now, we want the value of b. We want the value of b. Right. So, observe this equation. Observe this equation. Right. So, if you equate or if you collect coefficients of z square both sides, so we will get the value of b, right? Because here you'll get z square term, right? Coefficient of this z square is a, and here also you'll get z square term. Coefficient of this z square is what here b, and here we don't have left hand side. So you'll get a and b. A plus b is equal to 0. We can find here b very easily, right? Now collect or equate the coefficients of z square both sides. So here we don't have, so only z and constant term is there. Z square term we don't have, so take this as 0. This is equal to this side possibility. So here z minus 2 raised to 2, expand this, so you'll get z square term. So coefficient of this z square is a. Coefficient of this z square is a. So this is a, right? And here you multiply these two, so definitely you will get z square term. Definitely you will get z square term. So coefficient of this z square is b. A and this plus b, and here z minus 1 is there, so we don't have here z square term. So 0 is equal to a plus b, or a plus b is equal to 0, b is equal to minus a. We know what is a, substitute is equal to minus 2. Now we got a as 2, b as minus 2, and c as 6. Now substitute here. Where? Substitute. Where we need to substitute? Substitute here, right? So 4z minus 2 divided by z minus 1, z minus 2 raised to 2 is a divided by a is 2. 2 divided by z minus 1 plus b is minus 2. Minus 2 divided by z minus 2 plus c is 6. 6 divided by z minus 2 raised to 2. Right? Now, hence uz by z is equal to 2 divided by z minus 1, plus into minus is minus 2 divided by z minus 2 plus 6 divided by z minus 2 raised to 2. Now take this z, or transfer this z from LHS to RHS. Numerator, denominator comes this side, numerator. So multiply all the terms with what here? Z, right? So z into something, right? You will get u of z as z into this thing, right? So multiply z to all the terms. So 2 outside, z divided by z minus 1 minus 2 into z divided by z minus 2 plus 6 into z divided by z minus 2 raised to 2. Right? Now apply inverse z transform both the sides. Apply inverse z transform both the sides. So z inverse of u of z is equal to 2 into z inverse of z divided by z minus 1 minus 2 into z inverse of z divided by z minus 2 plus 6 into z inverse of z divided by z minus 2 raised to 2. Right? Now observe here. This is in standard form, no problem, right? And here this is in standard form, no problem, because z divided by z minus raised to n, so we can write. And here, see here, and see here, here only z term we have, only z term we have, right? So according to this, so z inverse of az divided by z minus a raised to 2 is n into a raised to n, right? Means we have only z term, so we want this a term, we want this a term, we want this a term. So what is a here? A is 2, a is 2, so multiply 2. So we need to balance the equations, right? So whatever we multiplied, we have to divide 2. We have to divide 2. Whatever we have multiplied, we have to divide 2. Right? Why? Because if it is z minus 2 or z minus 1, so we can write z divided by z minus 1, z divided by z minus 2. So this as 1 raised to n and 2 raised to n. Here z minus 2 raised to 2 is there. Means I need only this z term we have. Only this z term we have. I want this numerator as az. A is 2 means I need numerator as 2z, right? So here multiply 2. So whatever you will multiply, divide 2, because we need to balance the equation, right? We need to balance the equation. 2 divided by 2. So multiply 2, divide 2, right? Next, I want this 2z, right? So keep this as it is, and z minus 2 raised to 2 is as it is, and take this constant outside, because this is in denominator. So you'll get this as 6 by 2, right? So 2 into z inverse of z divided by z minus 1 is 1 raised to n minus 2 into minus 2 into minus 2 into z inverse of z divided by z minus 2 is 2 raised to n plus 6 by 2. Take this 2 outside, because I need only 2z. This I don't want. Take it outside. So denominator we have. So 6 divided by 2. 2 ones are 2 threes are. Z inverse of 2z divided by z minus 2 raised to 2. So this is nothing but, this 3 is as it is. This is nothing but n into a raised to n. In place of a, 2 raised to n. So this will be the required answer, right? So once again I'll explain. So here z inverse of what we have, only z divided by z minus 2 raised to 2 is there. Raised to 2 is there. So here I want a term. So a is what here? 2, means I want 2 here. So multiply 2, divide 2. So next step we have multiplied 2 and we have divided 2, right? We have multiplied 2 divided by 2, right? So we want this 2z, we don't want this 2, take it outside. So 6 by 2 will be what here? 3. So z inverse of 2z divided by z minus 2 raised to 2 is nothing but n 2 raised to n. So, and no problem for these two because standard result. So we have used these two results. We have used here these two results, z inverse of z divided by z minus a and z inverse of az divided by z minus a raised to 2. So observe this, right? So see here, 2z in place of a, 2, right? 2z divided by z minus 2 raised to 2. So this is nothing but n is as it is. In place of a, 2. So 2 raised to n. So this one, right? And this 3 is as it is. And no problem for this. So in place of a, 1, and in place of b, in place of a, 1, and here also in place of a, 2. So a raised to n, 1 raised to n, 2 raised to n. Understood? So we have used these two results, right? Move on to next example. Find the inverse z transform of z cube minus 20z divided by z minus 2 raised to 3 z minus 4. So this problem appears twice. So January 2010 and July 2013 of this video, right? Now, what is given? We want inverse z transform of this. So what is given? U of z. So u of z is given. So write down. So let u of z is equal to z cube minus 20z divided by z minus 2 raised to 3 z minus 4. Right? I want uz by z. I want uz by z. Now observe these two. We can z common, right? Easily we will get uz by z, right? Take z common from the numerator. So z common inside z square minus 20 and denominator will be same, no change, z minus 2 raised to 3 z minus 4. Now take this or transfer this z from RHS to LHS. So uz by z, this is equal to z square minus 20z because we have transferred this. Numerator comes this side, denominator. So uz by z. So this is LHS. So this is equal to z square minus 20 divided by z minus 2 raised to 3 z minus 4. Now we have to resolve this by using partial fractions. Now we can write z square minus 20 divided by z minus 2 raised to 3 z minus 4. This is equivalent to az square plus bz plus c divided by z minus 2 raised to 3 plus d divided by z minus 4 because already we have taken a, b, c. Next constant will be d. So d divided by z minus 4, right? Now proper substitution of this z, we need to find here a, b, c, d, right? So first taking LCM, right, we'll get here as z square minus 20 divided by z minus 2 raised to 3 z minus 4. So this is equal to 2 raised to 3 z minus 4. Z minus 4 is there, multiply z minus 2 raised to 3. So next step will be az square plus bz plus c into z minus 4 divide z minus 4 plus d into z minus 2 raised to 3 whole divided by z minus 2 raised to 3 z minus 4. Now denominator, both the sides get cancels, left with z square minus 20 a z square plus bz plus c z minus 4 plus d into z minus 2 raised to 3. Now proper substitution of z, we need to find here a, b, c, d. So first z is equal to 4. Z is equal to 4 means here you'll get this as 0, right? And you'll get the value of t, right? Substitute z as 4. So 4 square, 4 square, sorry, z as 4. 1 minute. Second. Right. Take z as 4. 4 square is, I'm right. So z as 4, because in place of z we are substituting 4. 4 square is 16. 16 minus 20 is minus 4. So how we got this as minus 4? Z is 4. 4 square is 16. 16 minus 20 is minus 4. And here 4 minus 4 is 0. 0 into something is 0. This term is 0. And here 4 minus 2. 4 minus 2 is 2. 2 cube is 8. 2 cube is 8. How will get this as 8? 4 minus 2 is 2. 2 raised to 3 is 2 raised to 3 is 8. So 8d. So this is equal to d is equal to minus 1 by 2. Take this 8 to this side. This is in numerator. Comes this side, denominator. Minus 4 divided by 8. 4 ones are 4 twos are. So d is equal to minus 1 by 2. Now substitute z is equal to 2. So substitute z is equal to 2. So we'll get here as 2 square 4. 4 minus 20 is minus 16. And here 2 minus 4 is minus 2. 2 minus 4 is minus 2, right? And this in place of z, substitute in place of z, substitute 2. 2 square is 4, 4a, plus in place of this z 2, so 2b plus c, and this z minus 4, 2 minus 4 is minus 2, and this will be 0. Once again I'll explain this one, don't confuse. Substitute z is equal to 2 in this equation. So 2 square 4, 4 minus 20 is minus 16 is equal to, in place of z 2, 2 square 4a, plus in place of this z2, so 2 into b is 2b, this c is as it is. 2 minus 4 is minus 2, and here 2 minus 2 is 0. 0 into something is 0, right? So here minus minus get cancels. 2 ones are 2 eights are. So we'll get here as 4a plus 4a plus 2b plus c is equal to 8, right? Next, we are finding here a b c d, right? So we got d, so we need to find a b c values. So for that, so put z is equal to 0. Put z is equal to 0. What we'll get, see here? So 0 square is 0. 0 minus 20 is minus 20 is equal to, and here z is 0, and here z is 0. Z is 0 means here what we'll get here? This term 0, this term 0, and here 0. 0 minus 4 is minus 4 into c. So minus 4c, right? Minus 4c. And here in place of z 0, 0 minus 2 is minus 2. Minus 2 raised to 3 is minus 8. So minus 4c minus 8d, right? Minus 20 is equal to minus 4c minus 8d. Once again, I'll explain here. So in place of this z, in place of z, substitute 0. 0 square is 0. 0 minus 20 is minus 20 is equal to z0, z0. Both terms are 0. And here you substitute 0 minus 4 and this c. So minus 4c plus d into, and here substitute z as 0. 0 minus 2 is minus 2. Minus 2 raised to 3 is minus 8d. Minus 2 raised to 3 is minus 8d. So we'll get here as minus 20 is equal to minus 4c minus 8d, right? So here we can cancel this, right? Minus 4 because you take minus 4 common, so inside will be c plus 2d, and here minus minus get cancels. 4 ones are 4 5s are, means we'll get next step as next step as c plus 2d is equal to 5, right? We know what is d, right? So c we want, so c is equal to 5 minus d. So substitute d value. So c is equal to 5 minus 2 into minus 1 by 2. 2 ones are 2 twos are, minus into minus is plus. 5 plus 1 is 6. So c is equal to 6, right? Next we want here a and b value. So for that, so equate the coefficient of z cube. So equating the coefficient of z cube, so expand this. So here you will get z cube term. So coefficient of this z cube is d, and multiply these two, so we will get z cube term. So coefficient of this z cube is what here? A. And here we don't have this side 0. So equating the coefficients of z cube both sides, so we'll get here as 0 is equal to a plus d. So a is equal to minus d. So we know what is a. We know what is d. We know what is d. D is minus 1 by 2. This minus 1 by 2 is minus into minus is plus. A is equal to 1 by 2. So how we got the value of a here? Equating the coefficient of z cube both sides. So see this equation, right? So z cube LHS 0. Here possibility, so multiplying these two, definitely we get, because a z square z, definitely you will get z cube term. So coefficient of this z cube will be a here, and here expand this. So definitely cube is there. So expand this, definitely z cube term. So this multiplying by what here? Coefficient of this will be multiplying with the d. So coefficient of this z cube is d. So 0 is equal to a plus d. 0 is equal to a plus d, right? So a is equal to minus d. We know what is d. So d is minus 1 by 2. So minus into minus 1 by 2 is 1 by 2. So a is equal to 1 by 2. Now from equation 1, so this is equation 1, right? So from equation 1, so we can find here b, because we know what is a and we know what is c. So we can find b here very easily, right? A is 1 by 2 and b is 6. So substitute and simplify, we will get the value of b very easily. So let us find. So from equation 1, 2b is equal to 8 minus 4a minus c, right? What is a? Substitute. What is c? Substitute. So 2b is equal to 8 minus 4 into a is 1 by 2 minus 6. 2 ones are 2 twos are. So 2b, this 8 will be as it is. Minus 2 minus 6 is minus 8. So 2b is equal to 0. 8 minus 8 is 0, right? So 2b is equal to 0. So b is equal to 0. Now substitute. Thus what we have? Z cube minus 20 divided by z minus 2 raised to 3, z minus 4. This is equal to z square by 2, and b is what here? 0. So 0 plus c divided by z minus 2 raised to 3 plus d is minus 1 by 2 z minus 4. Now take LCM and simplify. So this term you will get here as z square plus 12 divided by 2 into z minus 2 raised to 3 minus, because plus into minus is minus, 1 by 2 z minus 4, right? Now we can take here 1 by 2 outside. Take 1 by 2 outside, because 1 by 2 is common for both the term. Is z square plus 12 divided by z minus 2 raised to 3 minus 1 divided by z minus 4, right? Now uz by z is equal to 1 by 2 z square plus 12 divided by z minus 2 raised to 3 minus 1 upon z minus 4. Now here next step will be, so some adjustment we are doing, right? Denominator we have z minus 2. Denominator we have for this term, only this term. So denominator we have z minus 2 raised to 3. So here also I want, instead of this z square, I want z minus 2 raised to 2. Z minus 2 raised to 2, right? See here, denominator z minus 2 raised to 3 is there. So numerator also I want z minus 2 term. So in place of this z square is there. In place of this z square, I want z minus 2, right? So here for that, z minus 2 raised to 2, right? Z minus 2 raised to 2, a minus b whole square. What will get a minus b whole square as? A square minus 4, a minus b whole square is what here? A square minus 2ab plus b square. a square minus 2ab plus b square. Right. So z minus, we want in place of z as a z minus 2. We want in place of z as a z minus 2. Right. So first, what is z minus 2 raised to 2? Z minus 2 raised to 2 is z square minus 4z plus 8. Z square minus 4z plus 8. Right. So here we want minus 4z. We want minus 4z. Right. So 8 we can 8 we can get how from splitting this 12 as 8 plus 4, so we can get here 8, we can get here 8, no problem. And z square term is also there, right? Only thing is I don't have 4 minus 4z term, right? So minus 4z, so we have to balance the equation. Minus 4z we have taken and plus 4z, right? Means we need to balance the equation, right? So after cancelling this, we need to get here z square plus 12 only. So from this z square plus 12, so make this z as a z minus 2 whole square. So, right? So possibility is what here? Z minus 2 whole square. So expand this, what will get? Z square minus 4z plus 8, right? So from 12, 8 we can get, and z square also we will get. So minus 4z plus 4z. We want minus 4z, we have taken, and we have to give plus 4z, because after cancelling this, we need to get the same equation, right? So z minus 2 raised to 2 plus 4z plus 8 plus 4z plus 8, right? So here z minus 2 raised to 2. So expand this, what will get this as a z square minus 4z plus 4, right? Not 8 here, plus 4. So from 12, so by splitting this 12 as 4 plus 8, so we can get here 4 term. Only thing is we want minus 4z. So what we want, we have taken minus 4z and we have to give that, because we need to balance the equation. So minus 4 we have taken here, whatever we have taken, so here plus 4z, right? And we split this 8 as we split this 12 as 4 plus 8. So 4 we have taken, so left is what here? 8 plus 8 as it is, right? So we can write this z plus 2 raised to we can write this z square plus 12 as z minus 2 raised to 2 plus 4z plus 8 divided by z minus 2 raised to 3. And this is as it is, z divided by z minus 4, and this is as it is. 1 divided minus 4. So this is as it is, right? So this, how we got this as? So z minus 2 is there. So instead of this z, I want z minus 2. So expand this z minus 2 whole square. So z square minus 4z plus 4. So z square term is there. And 4 also we will get, because we can split this 12 as 4 plus 8, we will get 4. Only thing is we want minus 4z. So we have taken minus 4z. Whatever we have taken, we have to give, because we need to balance the equation. So minus 4z we have taken, give this plus 4z, right? And this 4 we have taken, we'll split this 12 as a 4 plus 12. We have taken here 4. So left with what here? 8, right? We have subtracted and we have added 4z, right? We don't have this, so we want minus 4z, we have taken, and we need to give, so plus 4z, right? Only that much. And this 1 upon z minus 4 is as it is, right? Next term, so this, how we'll write this as? Z minus 2 raised to 2 divided by z minus 2 raised to 3. So this divided by this, and this plus sign is as it is. 4z plus 8 divided by z minus 2 raised to 3. Right? Once again I explain. This divided by this, z minus 2 raised to 2 divided by z minus 2 raised to 3. And this plus is as it is. 4z plus 8 divided by this, z minus 2 raised to 3. No problem for this. 1 divided by z minus 4. Right? So 1 by 2. So here 2 and here 3. So 2 get cancels with this 3. Left with what here? 1 upon z minus 2. And take this z to this side. Z to this side. So denominator comes this side, multiplication. 1 by 2 is as it is, z divided by z minus 2, and multiply z to this term also, z into 4z plus 8 divided by z minus 2 raised to 3 minus z divided by z minus 4, right? Multiplying this z to this, right? We will get this term. Now, u of z is equal to 1 by 2, z divided by z minus 2 plus z minus 2 raised to 3 is there, right? Multiply this z. So, 4z square plus 8z divided by z minus 2 raised to 3 is there, minus z divided by z minus 4. No problem for these two because standard result. So, z inverse of u of z, this is equal to 1 by 2 z inverse of, taking inverse z transform both sides, taking both sides of u of z is equal to 1 by 2. This is as it is, z inverse of z divided by z minus 2, and this plus is also as it is, z inverse of 4z square plus 8z divided by z minus 2 raised to 3 minus z inverse of z divided by z minus 4. No problem for these two because standard result, z inverse of z divided by z minus a, in place of a 2 here, in place of a 4 here. No problem for these two. Write down 1 by 2 as it is. So 2 raised to n, a raised to n, a is 2, 2 raised to n, and here last term, right? And here a is 4, 4 raised to n. Only thing is this one, we need to bring this into standard form, right? So raised to cube is there, raised to cube is there. So we have z inverse of a z square plus a square z divided by z minus a raised to 3, right? So this is equal to n square into a raised to n, n square into a raised to n, right? So here a no problem, a is 2, a no problem, so a is 2, right? And here a z square is also there, right? A z square I want, and a square z. So here 4z is there, right? So 4 we can write this as 2 square. 4 we can write this as 2 square, means 4z also we have. Only thing is here 2z square, right? And here we want 2z square plus 4z. We want here, according to this, we want 2z square plus 4z. And we have 4z square plus 8z. Right. So this is possible, 2z square plus 4z. This is possible by taking 2 outside. So taking 2 outside, 2z square plus 4z, and z minus 2 raised to 3 is as it is. Right. So this is equal to 1 by 2, 2 raised to n plus 2 into this 2, right? This 2 into z inverse of 2z square plus 4 divided by z minus 2 raised to 3 minus 4 raised to n, right? This is no problem as it is. This 2 is also as it is. So this is nothing but raised to 3 is there. So this is nothing but n square into z minus a. Z minus a. In place of a, what we have here? In place of a, what we have here? 2. In place of a, what we have here? 2. So 2 raised to n, and this minus 4 raised to n is as it is. So z inverse of, we have used what? We have used this result, z inverse of a z square plus a square z divided by z minus a raised to 3 is n square a raised to n. This 2 is as it is. This is n square raised to 3 is there. So n square into, in place of a, 2 raised to n, right? This is required answer. So un is equal to 1 by 2, 2 raised to n plus 2 into n square into 2 raised to n minus 4 to n. So this is required answer. So today I'll stop here only. I'll continue tomorrow. Okay.